Welcome to a lesson with Dr. Powell. Let's take a look at how we can use a linear transformation describing a rotation to rotate a graph in the plane. Okay, so a graph like this, y equals x squared, if we move over the x squared, and so we have like y minus x squared is equal to 0, and we're looking at all the solutions of this, that's the same thing as making a function like this and thinking of what is the preimage of 0? What's the fiber over 0? What's everything that maps to 0 with this function? So that's kind of what we're looking at right here. Now, if we want to rotate the graph up here, let's think about what that is. So if we rotate it this way, so this point is really here, we want this point right here to be in the fiber of 0 of a new function, right? That's kind of based off of our old function f. So we want this point, what we want to do is we want to take this point and be able to throw it back into something that actually works for f to give out 0. Because we know that f of everything on this line, this curve will give us 0. So if we make a function that says take a point on the plane, or take an x value, that is, with a y value associated with it, like on a curve over here, and okay, so take a y value on a point over here, and then rotate it 45 degrees back the other way. And if it lands, okay, and if it lands on the original curve, then we want to include this point and the graph of the rotated figure. So in the rotated figure, all the points here, if we rotate them back 45 degrees, we want that to be in the original function. The way of expressing that is simply say point on the plane, and then you rotate it back 45 degrees, and then that should be a solution for f to be in this fiber. And if that's true, then it will be on that graph right there that's been rotated 45 degrees this way. So that's exactly what we do. What we say is pretty much we take this function right here, and we input into the function, we input the rotated image, so of xy. So xy is going to be, we're going to use a linear transformation to rotate it, but backwards 45 degrees. And that's going to be set equal to 0, and that'll be our equation. So the backwards rotation by 45 degrees, so going, so let's see what that means. So instead of going counterclockwise 45 degrees, this will be the function that takes us clockwise this way, 45 degrees. We just need to know what the image of E1 is, the standard basis vector. What's the image of E1 right here? Well, the image of E1 is right here in the unit circle. In fact, we can factor out a root 2 over 2, and we can think the x value is root 2 over 2, and the y value is negative root 2 over 2, but I factored that out. Now, let's see what happens to this basis vector. So E2, so 0, 1, it goes back this way. It goes to what we expect right here at 45, which would be root 2 over 2, root 2 over 2. So just a 1, 1 here. So this right here, this calculation should give me the equation for the rotated parabola. Okay, so let's see what happens here. Basically, this is the same as, let's see, f of root 2 over 2. And here, this is just a linear combination, x times the first column times y times the second column. And so we end up getting, so basically we get x plus y and minus x plus y. All right, so that's what we're plugging into the function, but I wrote this as a column, but it basically, it looks something like this. F of root 2 over 2 times x plus y, comma, root 2 over 2 times negative x plus y, equaling 0. So we plug these into our original function set equal to 0, and that should give us the equation of the rotated parabola. Okay, so let's go through that process and see what we obtain. Remembering what f of x was, it's y minus x squared. Okay, so we have f of x, y is equal to um, y minus x squared. Okay, and so we're going to put this in for x and that in for y. So this right here goes into the x spot. So squaring that. So this really is just 1 over root 2 if you're looking at it that way. So e squared is just a half. So we get a half, and then we get x plus y quantity squared. And then over here, we're going to get and I'll just think of this as 1 over root 2. See, because root 2 over 2 is just 1 over root 2. That's another way of thinking about it. So this would just be negative 1 over root 2x, and then plus root 2 over 2y, plus. Okay, let's see, oops, excuse me. Let's think about what I'm doing. Subtracting this, right? You're right, because this was x squared right there, and then this is what we get for y right there. Oh, and I said I was using 1 over root 2. I better be consistent here. Okay, 1 over root 2. All right. So something like this is equal to, and this set equal to 0. Okay, and that'll work. All right, so that's the equation of the rotated parabola. Of course, you could probably simplify this a little bit. And yes, it definitely can be simplified. But in any case, with or without simplification, here we go. There is the equation for the rotated parabola. Thanks for watching.